many times across the field, but most of it was colored.
So, I've mentioned permutations and combinations multiple times this year. Without looking, if you haven't already, do you know what the difference is?
Oh, wait. Yes. I can't remember.
I know it, but I don't. So,
Is permutation like all the different ones? It could be combinations of like the two could be in anywhere, but it has just the two.
So, when we talk about combining things, right? We talk about pizza toppings or mix-ins to your ice cream or things like that. Order doesn't really matter, right? If I get pepperoni, sausage, and bacon on my pizza, or bacon, pepperoni, and sausage, that doesn't matter. They're all going to be on there. If I'm looking at books in the library, and you just put them back wherever you want, Miss Rosie's probably going to get pretty upset because that is a permutation. There's an order. There is an order to the set, and when you pull them all off the shelf and say, what's the probability that I get them back up on the shelf in the right order if I don't know their numbering? It's tough. The more books that you get. Yeah, if I just had 3 books on the shelf, well, my odds are okay.
6.
6 different ways. If I have 12 books on the shelf, though, and that's not even that many, it's a lot more. So permutations and combinations are the difference between, do I order my data or do I just put it together? So this is my worst nightmare if I was ever a science teacher. You have 4 chemicals, and depending on how you put them together depends on the reaction that you get. Let's imagine that one of them creates an explosion. So, how many different ways are there, different orders, to mix these chemicals together? So you have an empty beaker in front of you, right? You are choosing what goes first, then what mixes into that, and this actually, there are these experiments. Depending on the order, sometimes you'll get like a reaction that causes like some kind of gas, sometimes it turns into foam, sometimes it turns into like a solid. So depending on the order that you mix things, depends on what's there when you put in the new substance and what happens. So when I go to start filling my beaker, how many options do I have? 4, right? Because I have 4 different substances to choose from. When I put my next one in, how many things do I have left to choose from? And by the time I get to the end, I have no options left. I just have one thing, so I'm not making a choice, but it's still happening. So that's why we show the times 1. It doesn't do anything. Because everyone likes to ask, do I really have to show that? What you're showing is that you made 4 things happen. First thing I did, there were 4 choices. The last thing I did, there was 1 choice. Of course, it does nothing in multiplication. But that tells me that we have how many different ways to combine these? 24. So if one of those ways created an explosion, what's your percent chance of blowing up? Well, like percent, approximately.
Let me think.
0.041.
What would be really close to?
0.25.
1/25th, right? What times 25 makes 100? 4. So you're about 4% chance of blowing up. I wanted to use fractions. I did use fractions.
He likes fractions.
So you see what I'm saying here? If we just want to talk about how many ways are there to put 3 toppings on your pizza, that's different because order doesn't matter.
You have pretty good chances of not blowing up.
You do. That's what I'm saying. So if you have a 96% chance of not blowing up,
Do you take those away? Well, what are your other options yield?
like steam, smoke, noxious gas that make you sick. I don't know.
Well, then why would anyone ever do that?
I'm joking. I'm making this up, but there are chemicals. I might grab Mr. Gavila and see what chemicals there are. So here's your formulas, right? The nitty-gritty math. We are now using the exclamation point. Talk to your science teachers. Okay, okay, don't maybe talk to them about that.
No, it's not like if you fail to make explosive gas is made, it's that you have burners.
I think
once
liquid
it
gas
explodes.
No, it is
So-
liquid gas.
What?
Wonderful.
All I know is it blows up because the meth house will blow up every time you do it. I just know that's problem.
Can we move on?
Yeah.
So, the fundamental counting principle.
And let's just remember this is all recording.
Well, now they know.
Well,
Yeah.
that's not
Now they know not to do
see.
meth.
Let's educate the
Yeah.
world.
Not to make.
The point is not to make meth, not to not do meth.
Yeah, making meth
Well,
is
I
okay.
mean,
as
that's-
long
Well,
as
don't
you
do
never
that
do.
either. Don't do it either.
My uncle got arrested.
Say no.
Okay,
So,
moving
what do
on.
you use a half?
Hey, moving on. So, our formula's here. Utilize the graphing calculator. Where in the graphing calculator do you find factorial?
Go.
Math.
Math!
Math.
Because we're doing math with symbols.
We're doing math.
No, we never do that.
So, the easy first menu, and then what are we doing? What type of math?
Number.
Probability. So, scroll over to probability,
And then hit 4.
and then hit 4.
Oh, there's an exclamation point. It looks so
So,
happy.
this
Math
does
is under
not
the alphabet.
mean 9!
Whoa.
That's 9 factorial. So 9 factorial is doing what? Anyone know what factorial does? What operation the calculator is quickly doing for us? Well, yes, but what kind? Up to or down to. Yeah, so factorial multiplies every number. Of course, you can look at this. Between that value and 1. So what we just did with those chemicals, however many options you have, that number, factorial, will yield how many different outcomes can happen. Now, permutations will end up with overcounting depending on what we're doing with it. So it depends on how many of them we are arranging. So if I'm only arranging 3 things and I have 8 to choose from, well, the first time I make that choice, I have 8 options. The next choice, I have 7 options. And the next choice, I have 6 options. And I don't use my 5, 4, 3, 2, or 1. So we get rid of the overcounting by dividing by the difference between what we have to choose from and how many spaces we have to fit. So if you are ordering a pizza from Domino's, you have a lot of toppings to choose from. But if you're doing their special, you only put 3 toppings on your pizza. So if you want to look at how many different pizzas could be made, well, it's not just how many toppings there are factorial, because that yields lots and lots of outcomes for if I do 1 topping or 2 toppings or 3 toppings or 9 toppings or 12. Like that yields all of them. So if I only want 3 toppings, I got 3 choices. I only fill 3 spaces. Make sense?
Okay.
Combinations, we have to get rid of even more overcounting because order doesn't matter. So actually that pizza, we don't care what order the toppings are in. We just want to say how many different pizzas can I order. So pepperoni, sausage, bacon, doesn't matter order. You take away even more.
I have a question. Could you, so like, it shows how you're dividing by, so for that top one on the left side, it's like 8 factorial over, I guess it would be 5 factorial.
Yeah, because the difference between them.
Could you actually do that on a calculator and would it give 336? Or
Yes.
Yes. So look right above
I
your
did it.
factorial. Straveler, explain it then.
What?
You said you did it.
Oh, the thing?
Yeah, how your calculator does that for you. Like all of them.
Oh, you plug it in?
2. Did you find the menu options?
Oh, no, I just did.
Oh, no, I have a question.
Okay.
Forget the question.
This is kind of off topic, but in like Chicago, why do they put the toppings underneath?
They
That's
just
what
make
Chicago
it easy.
style pizza.
Okay. So,
I have a question.
Calvin and Layton.
That's a real
Question?
I know. But
It does.
might be unrelated. So
Try.
I was wondering, the exclamation point, like, what does that represent?
Factorial. So that symbol is called factorial. It takes the number that you have in front of it and multiplies that by every integer between it and 1. Because it's listing, if I had 8 things and I was plugging them into 8 places, the first choice I have 8 options. Next choice I have 7, next choice I have 6. So that number on top, if you just did 8 factorial, would be how many different options, how many different outcomes there are.
It's like a big one.
So it is like a big old number.
By the way, it did work. Although I do have a question why this
40,320 ways to do that. But if I'm only actually choosing 3, So say we have 8 toppings. Let's go back to the pizza. I'm only choosing 3 of them. Then I'm not using 6 through 1. So I don't, or sorry, 5 through 1. So I divide by 5 factorial to get rid of those possible options. So you found it?
Yeah, so it works. Like you just type in 8 factorial
Mhm.
5 factorial.
Oh,
Question is.
there's a menu option to do all that.
Oh, no,
So go back to your probability menu. Hit math, go back to prob. Look at options 2 and options 3.
AR radio.
So if you're doing a permutation, 90.5 is my NPR choice.
Then my
You use
question-
NPR, so the number of things you're operating with, R, is how many arrangements, how many choices you're making. So try that. Hit 8, then go into the option, grab NPR, and then hit 5.
I do have a question though.
And by the way, you can go left on your way there.
6,000.
So it should look 8 space NPR space 5.
6,720.
Yes, yeah.
Yeah,
It
no.
equals 336.
Oh,
Three,
3.
not
Sorry. We're
Oh.
using 3 because it does 8 minus 3, and it plugs in the 5.
How's the way that you like paste it down?
Second entry. Second in the enter button grabs the. So if you want to do it again without going back to the menu, there's your 336. So the first one we did would be if our pizza was going to have 5 toppings, and if we cared about order, because pizza's easier to talk to. So if we had books on the shelf, we pull off the shelf with 8 books. Order matters when I put them back up. But if I'm only putting back the first 336 different ways. Now if I try to put back the first 5, there's 6,720 ways.
We have these formulas on the test.
Once you use them a little bit, you don't really need them.
We're
I won't- Like on our test, probably, but I don't want to say anything about the state test. 'Cause I'm not sure about. The formula sheet I showed you guys the other day is what I've seen.
My calculator like got all messed up, and for the example, I like plugged it in exactly.
It's you need to group your denominator.
Yeah, my question was in terms of how the calculator works with whatever exclamation mark thingy,
Factorial.
factorial.
Yep.
Does it need to be in parentheses? Because I could see how doing.
So you still need to group. Like the issue Strapper had there was he didn't group his denominator.
I didn't do that either.
So, but then it just runs through the whole thing, so it does the division, then multiplies it again. Instead of dividing by the thing that already got multiplied.
Okay, so like my thing, it did it right, and I just
Yeah. You don't need parentheses around like 4 factorial. But if you're using 4 factorial times 9 minus 4 factorial on the denominator, when you type in, you'll need parentheses down here.
Because my cousin would be, he like misunderstands that it could do 8 factorial divided by 5 times the factorial, which would get like a ridiculous answer.
Oh, yeah, I know what you're saying. No, it'll do factorials before it should do the factorials before.
Alright, so it's like that sort of operation.
Check it. Yeah, check it.
Well, I mean, that's what I did. I got 336.
So then do it with parentheses and check that you get the same thing.
Okay.
That's how you verify. Alright, so we go to the formulas, because now we can apply them and move fairly fast. So, it's nice that it's exactly what you think it is. Permutation, use NPR, combination, use NCR. So, what we're asking is how many different lunch specials are possible? So, what choices are there to be made? We can think this out. You don't have to just use formulas. So, we're choosing one from each of the following types: sandwiches, side, and drink. So, for my first choice,
Miss Johnson got the same answer with parentheses.
that's what I thought. I just wanted you to verify it, so I wasn't the only thing telling you. So, how many different sandwich options do we have, Carmen?
I got 50. Yeah.
No, sandwich, just sandwich.
Oh, just sandwich 6.
6. How many different sides, Caleb?
Sorry.
How many different sides
Of what?
do we have to choose from?
This thing?
Yeah, with us. 4. How many different drinks, Michelle? Is 9. How many? 5. Are you just gonna probably sit back there now that that is a school? And you get how many options? 120?
Oh, did you read full screen the cherries or whatever?
Yeah, that was LED. She did a killer job. The Discovery Day idea is actually she's going to redo her grandpa's old like leather rocking chair. She's going to reupholster it, but she wanted to practice on something less.
Did it work?
Yeah. Great. The curve, doing a curve is hard to do, like upholstering around a curve. So getting that fold right, it's kind of mathy. The more folds that you make, the smoother it'll be. You're breaking up the circle. All right, try this. Suppose you're trying to crack a code. This is why the longer your password is, the harder it is. There are computer programs to crack passwords. It will literally just run through every single combination of the alphanumeric.
Isn't that why some like things off like if you mess it up, if you like mess it up 10 times?
Yeah.
Because like there's a thing.
It locks you out for a little while.
No, there's a thing on iPhones where if you mess up, it has a completely
They'll
erase
wipe
data.
Yeah, because you could plug it in and use the software to guess passwords. And if it didn't have a max, you just keep failing until you get it right. So if my password is one letter followed by 2 digits, and actually using digits only lowers your chances a lot, because how many digits are there?
9.
10.
0 is a digit.
Yeah.
So 10. So the same digit can be used more than once. This, please off to the side, this is a situation called with replacement. Say I'm dealing a deck of cards, and I bet you I can draw a diamond. I'll make my chances decent. And I can replace, like I put the cards back in. How many chances do I have on the first card? 13 out of 52, right? If I don't replace, how many chances do I have on the second card? 12. Because I didn't put the diamond back in.
Oh, but this
If I want 2 in a row, you assume that you got what you wanted the first time. Because you're computing this outcome happening. So with replacement and without replacement, change how many options you have. If this was not with replacement, the second digit could not be the same as what we'd already gotten or what we'd already used, and that would lessen our options. So for the first one, we want a letter. How many letters are there?
26.
26. So we have 26 options. How many digits? We said 10.
10.
And with replacement, we still have 10.
Yeah.
Password.
Wait, do Androids have a like disabled thing?
Yeah, it locks you up for 30 seconds.
You
And
can
then
disable
I don't
it.
know what happens in the
My dad. It's
Now, hold on. So compare that. What if you throw one more letter on the front? Or actually, what if you throw one more anything on the front? Which if you actually start thinking about symbols as well, your chances get crazier. But let's say this could be a letter or a number. So if we throw in one more very specific,
93,600.
so when the computers like make it one more long, you're like, but I wanted to use that word. Your difference between 2,600 password options and 93,000, that's huge. That's probably only like minutes or maybe hours of a computer program's trying to crack it. But that is the difference between how many options do we have, how quickly are we going to guess it, and how long does it take. So I have, over at Lifetime, my password has to involve upper and lowercase,
Yes.
letters and numbers, and a symbol.
Yeah.
So the amount of combinations are very, very large, and there's a minimum. It has to be like at least 8 characters long.
Wait, doesn't that
So
doesn't by the fact that like they put a maximum on how long it can be and a minimum on how short it can be, doesn't that
they don't put a maximum.
don't
They put a minimum. They say it has to be, a lot of things where it has to be 6 or 8 or
Because
whatever
I know like
characters long.
certain like I know Gmail, I'm pretty sure there's a maximum of
I
how
don't think so.
Even if there's a
I think
maximum,
I've tried.
like when we do these problems, we're saying if there's only 3 digits or only 4 digits, not even a minimum. If you use minimum, and you accept everything,
Else.
yeah, it's exponential. Really, I want to say it would actually, like, is literally exponential. So you can download 8. This is a really old problem. So they used to have like just MP3 players. It was like a flash drive with a headphone jack. essentially.
Oh, I
Oh,
have
yeah.
that.
And
I used to listen to that.
And sometimes you would get them like in cereal boxes or whatever. I'm not joking. So sometimes they came with like, here's the hit music. So let's say you have 8 songs that you can put on this music player. This music player. If you play the songs using the random shuffle, so you don't know what's going to come first, but hopefully it won't repeat, this would be without replacement. If the playlist won't repeat till you play through it, that would be without replacement. So please somewhere notate this is without replacement. If I'm going to play through all 8 songs, that's just 8 factorial, and it's 40,320 options.
Wait, how much did an MP3 player cost?
Depending,
Like, you got them in
Very
how
late.
much is that?
not really like a cereal box. Like I forget where. You would sometimes just get like, it comes with barely any music on it. But there were other ones that were like, a gig or 2 gigs. So I mean that now you guys like snickered at thinking about that much limited space. But that was because all it did was play music. It had a very tiny OS that just was scroll through the lists and make choices. That's all the OS had to do.
I think we could make that.
So you go out there and you're messing with Miss Rosie and you knock a bookshelf of 12 books off. And you tell her that you're going to put them back up there in the same order without using Dewey Decimal System. Or anything.
I forget
12
it.
books, 12 options. How do we do that?
Great difficulty.
Just 12 factorial. Is there any over counting there?
No.
Because
That would be so painful.
you're using every option. You're using every book. You're filling every spot.
Oh,
You're not leaving any books off.
dang, that's a lot.
So this is what's come out.
479,001,600.
1,600.
And that's like a couple days worth.
Couple days, Caleb. You're taking years. Well,
So
not
let's
if,
imagine.
Not if you get it on the first try.
Let's imagine that it takes you a minute for every
Okay, that we ordered.
order. Yeah.
And you like lose track of where you are too, because you do the same thing.
So how can we figure out how many days this would take us? How many minutes in a day?
3,600. No,
I say divide by 16 and divide by 24.
Yeah, 3,600. The 60 times 60. Or no, 60 times 12.
Yeah.
Yeah, we're talking
I don't know
seconds.
what
60 times 24.
I'm
Yes. How many?
332,640.
Oh, is that the end result?
That's days.
That's days.
years.
Days.
911 years.
Holy Lord!
So, lots of permutations.
How many days?
It's only 15 years if you do
It's
one
only
a section.
900 years.
911. Yeah.
900 years.
Are there animal species that go extinct?
All right. The Environmental Club is electing how many positions? 3 positions. President, Vice President, Treasurer. Don't let people sucker you into that because you're good at math. They will try to. Trust me. So if if the group has 10 members and we're filling 3 positions, first off, what is this? Combination or permutation?
Permutation. I don't know.
Does order of leaders matter?
No.
Yeah, who's in what position
Oh,
matters.
yeah.
So it's not just pizza toppings. I don't care what order they get stacked. I've got a president, a vice president, and a treasurer. And let's say neither or none of them can hold multiple positions. So this would be permutation without replacement. So we're going to use our general permutation formula. And in your calculator, you can check if you know how to do this by using NPR. So 10, then you go to your menu, or you can copy one of the earlier ones. We end up with 720 different options for the outcome of this election. Questions on how we identify what we're doing and set this up? So we have 10 options. And we call this like 10 choose 3. Like it's a permutation where we're doing 10 choose 3. All good? So try this. 12 swimmers are going to compete in a race. We're finishing first, second, and third. Unless you just want a general winner's circle, you're going to care about order. So this is where people make their mistakes. When I'm typing into the calculator, I type in 12p. Three, right? I'm making 3 choices. So some people will go ahead and do the subtraction and get themselves in trouble. Like we did earlier accidentally. How many options, how many ways are you ordering, picking, whatever you want to say? And we get
1320.
So, this obviously goes back to like gambling, right? If you're just going to wager who wins, you have 12 options. That's not that hard, right? 1 out of 12, your odds are okay. But if you want to up your bet, say I bet who wins first and second. Now you're 12 options times 11 options left. Then if you wager the top 3 winners, gold, silver, and bronze, now you've got over 1,000 options to deal with. And your odds of winning are very, very small.
Is that why a lot of people don't bet at like horse races and stuff?
Yeah, if you like, so there are levels of gambling, funny enough because I was just in Kentucky, where if you just bet on the winner, your payback is not that great if you win. Because, okay, so you beat the odds of 1/12. But your payback, if you choose first and second, gets a lot better because your odds of winning got a lot worse. And if you do top 3, your odds of winning are very, very small.
You're a millionaire.
But, well, not necessarily. It depends on your bet, right? Because you get a return on your investment.
Well, yeah, my dad talked about how one of his coworkers, they have horse racing at the company. He's like, all right, I'm gonna bet on the very the least likely horse. You bet $100 with like one.
So then actually,
odds.
yeah. So other probability comes into play on how they've been ranked.
Yeah.
So this, we're just talking about like there's no previous knowledge, but yeah. So go on.
So it was like 1 to 400. You bet $100.
Yeah.
And you just made now it's just like a random bet. You made stupid money off of it.
Yep. And that's why you should not waste your money gambling. Obviously, you're going to make your own choices, but I'm just talking about the math behind it. And really, I'm explaining to you how many ways you cannot win.
It's not saying don't gamble, just don't waste your money.
Yeah, I mean, if you want to go do it, you can find legal places to gamble.
And it won't necessarily be a waste of money if you have ample money. Right?
They still be waiting.
Sure, if you make money that you absolutely don't care about, I would much rather have you donate it to a worthy cause.
A lot more.
So, you're choosing 4 books to read on summer vacation from a reading list of 12. Is this a combination or a permutation?
Combination.
I'm just choosing what to take home, right? I don't care what order they're in. I'm just checking all 4 of them out together. There are a possible 495 different groups of 4 that you could choose. So try out the guide. You got 8 freshmen all wanting to clean up the annual picnic. Only 5 of them can. How many different groups could you make? This also is like when we look at housing, like Chicago trips, or we're trying to make groups or whatnot. If you have 40 boys and if you're trying to make these rooms, how many different possible combinations could you guys end up asking for? It's very large. It's a group of 5 permutation combination. Combination, right? So 8 choose. How many are we choosing? 5. How many? 56. So there are 56 different crews that could possibly clean up the picnic. From 5. Maybe you like get free admission. You get to eat first or something. I know there's oftentimes perks to volunteering. A college student is choosing 3 classes to take during first, second, and third semester from 5 possible electives.
Third semester.
Yeah, it's, some colleges have first and second semester that are your like when everybody's there, and they'll call like a summer like a third semester. Sometimes they just call it summer semester.
How'd that degrade someone's ability?
You're right, because people have a bias inherent that summer school's a bad thing. So, how many possible ways can a student schedule these classes? Does the order matter?
Yes.
Yeah, because he's taking one first, then another second, then another third, with or without replacement. Without, right? I'm not going to take the same class over. So, it's a permutation. Use a perm. You can abbreviate it if you want. So, how do I set this up? 5P3. We're going to 5 options. Permutate 3 different ways. 60.
This one's a perm and then the other one's a cone.
No one's even seen that before, and that's can't even believe I haven't thought of that. Combination, if you shorten it, it's a comb. A perm is like a thing that you get done to your hair to like freeze it in a certain way.
And then home.
It's a really bad joke, but I love it. It's a bad joke, but it's great. All right, jury of 12 people. It's chosen from 35 potential. If you don't know this about jury duty, when you get called for jury duty, it doesn't actually mean that you're on the jury. It means you got to show up, and you might be on the jury. So they call a lot more people than they need, and then it's who shows up. So if 35 people showed up,
Is it first come, first served?
no.
No.
You don't really want to be on the jury necessarily. It depends on your personality.
They might kick you off because you're
Yeah, if you come in and you're saying all kinds of things that they're like, you're not going to be a fair
I've seen
jury.
a movie where
Do
the
people
jury
just say stuff so they don't have to be on it?
I'm pretty sure I'm not.
The one time I got called for jury duty, I was in college, so all you really have to do is say, I can't come home. I have pre-existing commitments, like, and I'm not even living here now. And then move on to the next person.
I don't think I'm allowed to be on a jury.
But you get paid to be on jury, like, to be a
Do you
juror.
get paid a lot?
No. But I mean, say you weren't working a very good job, and a lot of places, like, if I got called for jury duty here, I could probably get it, like, it wouldn't be docked against me. They're just like, wow, well, that's your responsibility as an American citizen, so.
Isn't it also illegal to lie on a jury?
Yeah, it's perjury.
Yeah, it's mandatory to go to.
No, that's when you, like, are against your own country.
Well, yeah, but I've gotten like in federal law, it was considered treason to lie on a jury.
Maybe.
Actually, no, sorry. That was if it's a political like official and you lie on the jury, it's considered
This is
treason.
one reason why I thought it was happening was watching. This is more interesting. We get so far off topic. Okay, does order matter?
Yeah.
No.
How much you really care what seat you get? It's just a group of 12 people that are going to end up in a room, and they're going to have to decide guilty or innocent. So this would be a cone combination. How many options do we have when we start? 35. We're choosing 12 of them.
834,451,800.
Okay, I thought I was
451, 800. Yeah, you're right. You're getting a really big number. That's how many different groups of people could be that 12. Maybe you shouldn't sit in your hand. Or I can look the other way if you like me to stab me.
I'm down.
I'm
Do it.
joking.
Do it.
Don't hurt each other at school.
Can I get out of the splash zone?
Wait till you leave. So, here's the thing. When you think about a jury, that's the group that's going to decide whether you're going to jail or not. And there's 834 million different combinations of them. And the personality combinations are going to kind of determine, well, okay, hopefully you assume your guilt or innocence determines whether you're going to go to jail.
This group.
But, yeah, don't end up having a jury decide your fate.
There's no double jeopardy though, so you can't do that.
Yeah.
There was when my dad was working as a prosecutor, one of the things like the city of Ohio did was they took a group of like 25 people and they gave them like a mock trial case and they asked what verdict they would give, and then they took the number, like what possibility it was that person would have been convicted guilty or innocent,
Mm-hmm.
and then they like gave it, like they ran multiple scenarios to
Yeah.
determine like bias in situations. It was
Right. If
So
it's
it's
just
like,
like came down to a
If
straight
you know, and they sometimes give the same case, like with the same detail, with different people. And one of them
Excuse
was
this interruption. Could I have Julian Cargiatis to the office,
One of them
please?
was like as simple
Julian?
as if the person dressed nicer than someone who didn't,
Yeah.
they were given 15% more likely chance of not getting a guilty verdict, even
Right.
if his scenario is the exact same. It was just by the fact of how the person talked and acted.
The bias.
15%.
That's why most rich people.
Actually, no.
Well, there's
rich
other
people,
reasons I can go into
rich
that.
people
We
actually
gotta,
in this case
hey, we gotta
more-
get through this. So, mix-ins to your ice cream, your smoothie, your yogurt. Does order matter?
No.
No, so we are using a combination. Well, yeah, I guess this, you could get the same thing twice, but that wouldn't really, depends on how you view if it was like a double scoop or not. So how many different smoothie combinations? If we're doing 3 different mix-ins. So 10, choosing 3, we get
720.
720. So when you're standing there and you're saying, I can't make up my mind, well, you really do have a lot of options. You not only have 10 things in front of you,
show my mom this.
but the combined flavors of them, 700 possibilities.
But most of those probably you don't like.
Yeah, like gummy bears and Reese cups. I don't know that those go well.
I like gummy bears.
I thought you said it.
It's
What?
frozen.
Did you just doubt that there's gummy bears at those places? Cold Stone has gummy
I didn't. No, I didn't doubt that. I thought you were saying at all, like in any ice cream you don't like.
Oh
Reese's
no,
Cups.
I was on like a sherbet.
I'm telling my mom that.
I thought that was wrong.
And that's only just with 10 options. Those places have a lot more than that.
There's like 20.
Oh my gosh,
Did
that's
you
like
go
what?
10
Oh.
choose 3?
Oh,
it's
no, no,
What?
I was wrong. I was
No,
wrong.
wait.
What?
I was wrong. I hit the wrong thing.
What?
Did you permutate instead of? Yeah, sorry. That was if order mattered. So just go ahead and cross that C out and make it a P. So if we do 10C3, that seemed like a lot.
I was never.
That's okay. So there's bias. I trust what you say, and I just moved right on.
I got some.
One, you permutated instead of combined. So that would be
No, I
if
still
order
have
mattered.
some.
If you were ranking the best
My
toppings,
order,
or
my answer sheet, I put the same exact thing. Did you use
Yeah.
P instead of C? No, I
No, I didn't.
You used P.
I think so.
and P, you had P. Yeah. They're just one option away from each other. So be real careful. That was a great example to show how different of results we get.
What's the combination of figures that make this shape? So you have
What?
this set, and then you
Wait,
have
what was
this
the
set,
answer?
and then you have this set.
What was it?
Well, yeah, but it's gotta be these 4.
So actually, we could go back in and look at the comparison of the formulas and show why there's a difference of 600 possibilities there. So 600 possibilities were the overlap of the same toppings or the same mix-ins in different arrangements. So the amount of overcounting between a permutation and a combination is the difference of arranging them differently. Does that make sense? That there were 120 ways to choose. Then there were 600 ways to rearrange the choices that we had made.
Oh, because there's 3 spots and 6. You just multiplied it times 6. Yeah, that's cool.
So that's the difference between combinations and permutations. So probability of an event occurring. We know our P way of notating this. So P parenthesis probability of. What are we saying? Possible number of ways to choose 5, 7, and 9 on billiards balls.
No, I thought. Oh yeah. I thought you were talking about.
Billiards.
The beach ball.
So they're numbered 1 through 15. 8 ball plays both teams. Both teams have 7 of their own. So we are talking about combinations here. Just another showing out example for you. So let's check out the got it because we're running out of time.
Wouldn't the 8 ball be weird?
How?
Wouldn't the 8 ball be weird?
They're talking about numbers. They don't care team here. We're just talking numbers of the ball. So 3 pool balls are randomly going to be chosen from a set numbered 1 to 15. Obviously it's 1 to 15. What is the probability of choosing first the number 1, then the number 2, then the number 3? So you're trying to get somebody to take a bet, right? You say, I bet I can choose one of these. Bet $20, I'll choose one of these. Right, like I'll blindfold myself, whatever. The probability of getting one is just 1 out of 15. Right, so that's not that bad. Then if you say, I'll choose the first one as a 1 and the second one as a 2, your odds get a lot harder. So what are we doing here? If order matters, it's a permutation. How many do we have to choose from?
15.
We are making how many choices?
3.
And we get
We get 12,730. Everybody get that too?
now what are we going to do with this to find the probability of you actually doing that?
2,700.
I got 2,000.
Oh, yeah.
Guys,
I was about to say.
It's been a long weekend. You wrote it again.
It's, 2,700.
you're right. It's been a long weekend. 2,730.
And
Yes.
like daylight savings and everything.
That
I had
is.
to wake up at 6:30.
I woke up at 5:30.
Yeah, but what time were you living when you woke up? So then probability of actually doing that. So this, hold on, hey, stay with me, I got 2 more minutes. This is how many different 3-ball arrangements there are. What am I betting? Am I just saying I bet I arranged 3 balls in order, or like
Wouldn't it be 1 over 2,730?
it's 1 over this because we're talking about 1 arrangement out of all of the 2,730 for only choosing 3. So 1 out of our 2,730,
Man, that is
we get what as our decimal?
0.0366, and this is decimal. This is
Does it repeat out?
Yeah.
Yeah. So then, percent-wise,
No, this is the percent.
oh, that is the percent.
Yeah, like I did time.
So
Yeah.
0.0003.
You didn't play yourself if you made that one.
Yeah.
No, you still have a chance.
Oh,
So
less
my
than
buddy
1%.
Dave-
Less than 1%.
Still a chance.
My buddy Dave, when we play euchre, always, always,
That's right.
when he starts dealing, because we play first blackjack is like the dealer. So when we're determining who is the first black or who's the first dealer, when he goes to flip the first card, he always tries to say what it is. Now, when he gets it right, people are amazed. I sit there and I'm like, Dave, it's not that card. How many who plays euchre? How many cards are there in euchre?
I think 7. No, it's like,
No.
I thought you tapped
You still play cards 9 through ace,
Yeah.
all 4 suits still. So 9, 10, Jack, Queen, King, Ace. There's 6 of each. So 1 out of 24. It's exactly what we started with at the beginning of class chat. That's about that's a 4% chance, right? About 5%. Sorry, no, it is 4%. Very, very close. Yeah, but when we play games as much as we do, and he does it as much as he does, it's bound to happen eventually.
It's like a magic trick.
So
You
it
know,
goes back to the law of large numbers. All things will like pan out eventually. If you're rolling a die, you'll eventually get those 6s. Even if you're playing a game, you're like, oh, no 6s are coming up. Eventually, 6s are going to roll. Eventually, he'll get it right. And if he stays with the same guess, eventually it has to happen, right? Because one of those times it's going to come up. Who knows how long it'll take him, but it will. Yeah, you guys
David,
are right, though.
he sounds pretty awesome.
He is pretty awesome. He's like the game master. So if there's a way that during May term he could come in,
Yeah, because like you're doing that because
I don't
you said that
know.
he
We
like
need to do some outdoor classroom stuff. So if we do games for May term, we need to do outdoor classroom as like a club. So
I was like, you didn't have an outdoor Friday.
I might
Is
do
he gonna
outdoor
give us the
classroom
homework?
as
I will
just
do
a spring
all the
club.
Oh.
Like so, like at break, go change and like let's go work on the outdoor classroom.
Speaking of games, I
Oh, we
made
have
a
global
game for
life.
Discovery Day.
Huh?
I made a game for Discovery.
What game?
I
It's
made
trying
a
to
card
make a
game.
card
A
game.
card game.
A card game.
And I sent my order to this place and they're purchased.
Nice. That's sweet. Bring it in once you get it.
Okay. They said like 13 business days.
Yeah, they might get here faster than that. A lot of times they over.
Are you gonna give us the homework?
Oh, that would be beneficial. I'll come to Conan's class. These people already left.
Cullinan.
Oh yeah. This is a really easy homework.